Good morning, Math 30s. This video is going to correspond to lesson number 2 in permutations and combinations. A lot of the examples that I'm going to do are from the workbook. However, I'm following my own note package, so you might want to have the note package ready to go in front of you. And if you don't have one, a blank copy is available on the Google Classroom. I'm going to skip this page for now. I will come back to it at the end of this video. And just to make note, this lesson, so lesson 2 in the workbook, will be done in 2 different parts. So just flip to this page here, and we're going to look at one of the homework questions, and I'm going to show you how to do it in an alternate way from lesson 1. So you did a homework question that said, how many ways are there of arranging 6 different books side by side on a shelf? So 6 different books, imagine that you have in front of you, and that would be 6 stages, right? And in your first stage, you have 6 choices of books to put in that first stage. In your second stage, once you put one book on the shelf, you've got 5 books left to choose from, then 4 books to go into the third stage, a choice of 3 books there, 2 and 1. So if you did this question using the fundamental counting principle, which you would have, the answer of the number of different ways of arranging 6 books would be 720 different ways. What I'm going to teach you now is we can actually use something called factorial notation in order to deal with questions that involve the fundamental counting principle. So what factorial notation is, I'm just going to write, I want you to make a little note up here. So factorial notation, it's a shorthand notation for multiplying descending sequences. So for example, this would be considered a descending sequence. 6 times 5 times 4 times 3 times 2 times 1. This would be a descending sequence. And if I was to write this in factorial notation, what I would do is I would take this number here and simply write 6, and then it looks like an exclamation mark, and it is, but we call that in math the factorial symbol. So that would be the sign for 6 factorial, and then if you enter that into your calculator, and I'll show you how, what happens is your calculator will do the computation for you, and it will compute 6 times 4 times 3 times 2 times 1. So if you take out your calculators, I'll show you where that is. You're going to hit the math button. Sorry, hit number 6 first because we want to do 6 factorial. So it's under the math button. And I'm going to scroll to the left twice because I want to select probability. Or you could go to the right 3 times. I'm just going to go to the left twice. And then there is your factorial button. So it's number 4. So if you enter 6 factorial and then hit enter on your calculator, we will get the answer of 720. Okay. This question here was a diploma question, and it was multiple choice, and this was a standard of excellence question. So SE, if you see that on my notes, that just means standard of excellence. So if all the letters in the word diploma are used, so if you count up the letters in the word diploma, 1, 2, 3, 4, 5, 6, 7, how many different arrangements are possible that begin and end with I, O, or A? So begin and end with I, O, or A, they're introducing restrictions for us. So they want to begin or end with I, O, or A. Okay, so I, O, or that would be, there's 3 possible letters that could go there. And then remember that once you use a letter, it's gone. So there's 2 remaining letters choices that would go there. So then from the 7 letters that I had total in diploma, I've just placed 2 of them, right? So that would give me 5 remaining letters. So then I would have 5 choices of letters to go there, 4, 3, 2, 1. So yesterday in your homework for lesson 1, which was just on the fundamental counting principle, this is what you would have entered and you would have gotten the answer. However, the options available introduce factorial notation. So how this could be rewritten is the number 3 times, this is our descending sequence. So 5, 4, 3, 2, 1 is our descending sequence. So that would be 5 factorial, and then times 2. So 3 times 5 factorial times 2, and your correct answer was D. If you punch that into your calculator, so let's see what we would get as that answer. So 3 times 5, math button, 5 factorial, times 2 gives us 720 choices for this option. Okay, next I want to show you is that 6 factorial can be written in a variety of ways. So we know that 6 factorial is a shorthand for multiplying a descending sequence, so I could do 6, 5, 4, 3, 2, 1. Or I, for example, could say, I'll just talk about this one. 6 factorial is equal to 6 times 5 times 4 factorial. So if I don't want to actually finish off to the end, I could write this. And the reason is because you know that 4 factorial is simply 4 times 3 times 2 times 1. Right? You could also write 6 factorial is the same thing as it's going to be equivalent or equal to 6 times 5 factorial. So you take your 6, and normally we would say 5, 4, 3, 2, 1, but I could say instead of that, just 5 factorial. So there's different ways of writing, a variety of ways of expressing 6 factorial. Okay. Let's simplify some quotients. So 6 factorial divided by 4 factorial. Yes, you could punch this into your calculator, but you're going to see later on it's going to be really helpful if you're able to simplify. So what you always want to do is, we call this unzipping, and you always want to look for the larger factorial. Okay, so the key to this is going to be looking for the larger factorial. That's the one that you unzip. So between a 6 and a 4, the larger factorial is the 6. So that's the one that I would start unzipping. And you're going to unzip it until you get down to 4. So 6 factorial would be 6 times 5 times 4 factorial, all over, my denominator has a 4 factorial in it. Then 4 factorial and 4 factorial would cancel. So my answer is 6 times 5 without punching it onto a calculator, and 6 times 5 is 30. What I want you to try is try this one. So 10 factorial divided by 7 factorial. See if you could simplify this without using a calculator. So this would be a fair question in calculus where you can't use a calculator, right? So you'd say, okay, I'm going to start unzipping the larger one, which is 10 factorial, and you're going to unzip it until you get to 7 factorial. So that would be 10 times 9 times 8 times 7. And then because I see the 7 in the denominator, I'm going to stop. And my denominator is 7 factorial. 7 factorial and 7 factorial would cancel. 10 times 9 times 8. If you weren't able to use a calculator, I would start here. 9 times 8 is 72, and 72 times 10 is 720. Okay, for this one, again, you're going to do the same thing, and you always start unzipping the larger factorial. So that would be the 8 factorial. And basically, I'm going to stop when I get a 5, because what the goal is to cancel what we can. So 8 factorial would be 8 times 7 times 6 times 5 factorial. And then in my denominator, there's the 5 factorial. And I have a 3 factorial. Okay, so now I could cancel 5 factorial and 5 factorial. So I can do this. Then what I'm going to do is, you could compute it from here, but I'll show you another sort of thing that you could do if you're doing this by hand. 8 times 7 times 6 is what we have in the numerator. In the denominator, I have 3 factorial, which you know is 3 times 2 times 1. Well, 3 times 2 times 1 is 6. So I've got 6 down here and 6 up here. So what I'm going to do is I'm going to cancel this 6 with that 6. And then my answer is simply 8 times 7, which is 56. Okay, so with factorial notation, there's a general way that we could express it. So we know, for example, that if I gave you 8 factorial, we know that that's just shorthand for multiplying a descending sequence. So 8 factorial would be the same thing as 8 times 7 times 6 times 5, all the way down to 1, right? So there is a way that we could shorthand this. And what I'm going to call 8 is I'm going to say whatever number you're given, that's the number n. Okay, so that's n factorial. And then what happens is each number after it would be, so we would write n, right? So I'd write 8. And then the next one would be n minus 1, which would be 7. And then after that, it would be n minus 2. And n minus 2 would be 6. And we keep going on until we get down to 1. One thing that's important to remember with this is that they tell us that n belongs to the set of natural numbers. So remember that natural numbers are kids counting numbers, and kids counting numbers, like when you ask yourself, well, how do kids count? If you say to a kid, like, count to 5, they will always start at the number 1. So 1, 2, 3, 4, 5. Those are natural numbers. Basically, 0 is not a natural number. So when we do this, the general form of writing or of expressing factorial notation, it would be n factorial is equal to n minus 1, n minus 2, and we go all the way down to 1, and then it would be comma, n belongs to the set of natural numbers. This is on your formula sheet. So this will be given to you on a test. I'm going to show you how you would apply it. Okay? So let's look at these two examples right here. So we'll look at this guy and we'll look at this guy. And we're going to do the same sort of thing as we did here, where we look for the largest one and we start unzipping it. So how I often will teach this to students is I will say pick a number for n. Like sometimes students have a hard time seeing which one the numerator denominator is bigger. So I say, well, just pick like a random value for n. And let's just say I said n is equal to 10. So if n was equal to 10, this guy would be 8 and this would be 9. Okay? So where we want to start is where we start unzipping whatever's larger, and in this case, the denominator's larger. So what comes after n minus 1 would be n minus 2, then n minus 3, n minus 4. And what we want to do is we want to start unzipping this until we get to n minus 2. So n minus 1, if I was to express that, that would be n minus 1. And then next would be n minus 2, n minus 3, n minus 4, but I stop when I get, and I match it with that. So n minus 1, n minus 2 factorial, and then in the numerator, it would be n minus 2 factorial, n minus 2 and n minus 2 would cancel, and what we would be left with is 1 over n minus 1. Okay? That's a simplified expression. So let's look at this one. Let's do the same thing. We have n factorial on the top, and I've got n times n minus 1. So we would actually start unzipping up here with this n factorial. And what we would get is n factorial is the same as n minus 1, n minus 2 factorial. On the bottom, because I have n, and n minus 1. And so now you're going to see that this will cancel and this will cancel. And the reason why I kept one more is because they want me to like simplify this expression. So n and n would cancel, n minus 1 and n minus 1 would cancel, and what I would be left with is n minus 2 factorial. Okay, let's do this last question. And then I'll give you some practice for the homework, and that will be the end of part 1. I will set up one of the questions with you. I might do one more of these questions just to make sure that you're good. Algebraically solve this equation. Okay, again, look at the numerator and denominator and see if you could figure out which one is bigger. So if n was equal to 10, I would have 10 up here and 8 up here. So, or 8 in the denominator. So I'm going to start unzipping this, and I'm going to stop when I get to an n minus 2, because I want to cancel. So n factorial is the same thing as n times n minus 1, n minus 2 factorial. And I would stop, because now in the denominator, that's what we had, n minus 2 factorial. They said that this was equal to 42. So n minus 2 factorial over n minus 2 factorial cancel out. What I have now is I have n minus 1 is equal to 42. From here, I'm going to distribute. N squared minus 1n is equal to 42. And we're going to have a quadratic form. We're going to have a quadratic. So we're going to be factoring. You want to bring everything to one side of your equal sign. Always go to the side that makes your n squared positive. So everything would be going to the left. Okay. Ask yourself, what gives you a product of negative 42 and a sum of negative 1? So product of negative 42 and a sum of 1 would give you an answer of 6 and negative 7. So writing this, we would have two factors. One of my factors is n plus 6, and one of my factors is n minus 7. You need to set each factor equal to 0 and solve. So this factor, n would be equal to negative 6. This factor, n would be equal to 7. One of these you need to reject. One of these is going to be an extraneous root. And in this example, this is the one we would reject, and you have to be able to understand why would we reject this. So let's just write that this is what we would reject. Remember that I said when we do factorials, we get down to the number 1. So we get down to the kids counting numbers. So if you go up here, n always has to belong to the set of natural numbers, of kids counting numbers. So whenever you get two answers, because you will be doing a lot of quadratics, whenever you get two answers, the negative answer is always rejected. And the reason is n must belong to the elements of natural numbers. So my value for n would be 7. Okay? I want you to, before you watch the second part of this video, I want you to do the homework. So I've got the homework listed for you here, 1, 2, 4, 5, ABC, 6, ABC. And I think what I want to do, one more class example. So if you can take out your workbooks, I want to do class example 2A with you, and then I'm going to set up 6C. So in your workbooks, let's do class example 2A together, just so that you could get a bit more practice with this. Okay, so again, let's pick the number 10 for n and figure out which one do I start unzipping. So I've got n plus 2. And I've got n. So if I had 10, this would be 12, and this would be 10. So you always start unzipping the larger, which would be this guy here. Okay, so how you would do this one is you would say n plus 2 is the first one. The next one, remember it's always one number less. So n plus 2 minus 1, that would be n plus 1. And then n plus 1 minus 1 would be n. And I'm going to stop there because it would be n factorial, right? And then I'd say, well, what would be next? N minus 1 factorial, n minus 2 factorial, n minus 3 factorial. Okay, from there, our denominator was n factorial, so I'm going to put that in the denominator. Numerator and denominator would cancel. So the simplified expression for this would be n plus 2, n plus 1. That's good enough as the answer. If you expanded this as well, I would be okay with that. So you could do either or. The one that I wanted to set up, I said, let's see which one I'm setting up with you. I'm going to set up 6C. So let's look at the homework for 6C. So in the homework, I think I eliminated 6D, so you could cross that out. And let's just have a quick look at 6C. Okay, solve this equation. So again, if you begin to unzip, you always unzip the bigger one. So if n was 10, this would be 12, that would be 10. This is the guy that unzips. So this would be n plus 2. When we subtract 1, we would get n plus 1. When we subtract 1, actually, and I'm going to quickly set 6b up as well. When we subtract 1, what do we get? N factorial. All over n factorial is equal to 12. N factorial over n factorial will cancel. And then you're going to have your quadratic. So n plus 2, n plus 1 is equal to 12. From here, expand, bring the 12 over, and you're going to factor that. So I think the one that I had actually wanted to set up with was this guy. What you want to do when we're solving, always make sure that you have your constant or a number isolated. So I've got a 6 on here, I've got a 12 here. We want to isolate this 6. So get rid of that n minus 1 factorial by dividing both sides by n minus 1 factorial. That's gone. And then what you would be left with is n plus 1 factorial all over n minus 1 factorial, which is equal to 6. You want to start unzipping the larger of the two. This would be larger of the two because if n was 10, that would be 11. So that would give you n plus 1, n minus 1 factorial, all over n minus 1 factorial. That's equal to 6. Cancel out your factorials, and then you're going to have, if you distribute in this n squared plus 1n is equal to 6. Bring your 6 to the left and factor.